Hello students, good afternoon to all of you. You are most welcome in next video lectures of LNT College Online Studio. Okay, so in this particular lectures, we will basically focus on alkali metal ozonides, right? And ozonide means it is the next allotrop of oxygen, that is oxygen O2, right? So it forms O2 minus, right, that is superoxides. So once they react with oxygen, okay, they forms O3 minus, right. So this is actually 2 and this is also 2. So once 2 mole of superoxide react with another oxygen molecule in the gaseous phase, so result in the formation of 2 mole ozonide. This is what is called ozonide, right? Ozonide means, so O3 minus. This is called ozonide, right? So what is the chemistry of ozonide? Ozonide has 19 valence electron, right? So again one electron is extra and total 18 electron will remains in paired state. So due to presence of one additional electron, so they are paramagnetic. It is paramagnetic in nature, paramagnetic in nature, right? So it is tri-atomic compounds. So it is tri-atomic in nature. And what is the structure of this ozonide? So OOO, right? So it has overall -1 charge, right? So it has bent structure similar to the ozone. So this -1 negative charge will be equally distributed on each oxygen atom. So the resultant structure look like that, -1 by 3, -1 by 3, -1 by 3, right? It means this ozonide structure possess 3 oxygen atom through the covalent bond, and each oxygen atom carries -1 by 3 negative 1 by 3 charge. It means negative 1 by third on each atom indicates the oxidation state of oxygen atom in the ozonide, that is -1 by 3. So the oxidation state is -1 by 3 is again low compared to peroxides. It means oxidation state -half in case of peroxide, right? Again -1 by 3 in case of ozonide. So low charge density on oxygen atom, uh, and this low charge density, but the size of the ozonide, that is O3 minus, is again large compared to O2 minus, right, or peroxide O22 minus. The large size, it has large size, okay. So large size ozonide anion will be stabilized by large cation, requires large cation to stabilize this structure, right? So what is the chemistry, how it forms? So the formation of alkali metal ozonides like lithium, right, oxide, lithium oxide Li2O, once react with oxygen, right? Oxygen in the presence of liquid ammonia, so it can form LiO3 in liquid ammonia, right? So, or you can say that, so in once it reacts like LiO2 superoxide, once react with oxygen to forms LiO3 in liquid ammonia, right? In liquid ammonia. So this is lithium ozonide, okay? Or it can be prepared by ion exchange reaction. Suppose we have a cesium ozonide. If it react with potassium in a liquid ammonia, so then it forms KO3 and cesium outside to the sphere, right? So this is potassium ozonide. This is potassium ozonide. So all alkali metal of the group first actually form ozonides. So what is the order? Like LiO3, NaO3 and KO3, RbO3 and CsO3. So these are alkali metal ozonides, right? So this cesium cation, right? Cs plus and ozonide ion, right, will be most stabilized large cation, right? Large cation and large anion. So as per Fajan's rule, larger cation will stabilize or accommodate larger anions. So the most stable ozonide is cesium ozonides, while lithium ozonide is least stable because least stable least stable. So because of the small and highly charged lithium cation, ozonide ion will not be stabilized in the lattice structure. It means Li plus destabilizes, Li plus destabilizes O3 minus, right? So similarly, sodium ozonides, potassium ozonides, they are not stable, they are highly reactive. And all these compounds are potential oxidizing agents. So they are highly potent to oxidize another compounds. So they are all oxidizing agent, right? Oxidizing agents. So suppose we have potassium ozonide, potassium ozonide KO3. It is thermodynamically unstable and it will undergo decomposition reaction. So it will again decompose into superoxide plus half mole oxygen gas. So ozonides are actually source of oxygens. So all ozonides can regenerate oxygen in the atmosphere. So this is the beauty of ozonides. So this potassium ozonide and this is potassium superoxide. So these are paramagnetic because it contains superoxide ion in the structure. So that is why all ozonides are paramagnetic in nature. Okay, so this potassium oxide actually is industrially very important. So it can react with H2O, KO2 react with H2O. So once potassium superoxide, it react with this H2O molecule, so result in the formation of potassium hydroxide and H2O2 hydrogen peroxides, right? So because of the formation of hydroxide, so it is plus oxygen, oxygen gas. So once this react with water, so they will release again oxygen in the atmosphere, right? So this is the beauty of this superoxide. So once it will react potassium superoxide, if react with carbon dioxide in the atmosphere, so what actually happens is that it forms K2CO3 potassium carbonate through the release of oxygen gas in the atmosphere. So it will actually used as a uh, compounds to maintain the sustainability of human lives on the earth. So because it will act as a regenerator of oxygen and also acts as a remover of carbon dioxides, right? So this carbon dioxide from the atmosphere can be removed through the absorption of this superoxide. It means superoxides can absorb CO2 and remove it from the atmosphere by releasing oxygen gas. Now, if this superoxide, that is potassium superoxide, react with carbon dioxide in presence of water, right, H2O. Suppose H2O consisted with excess CO2, right? Excess CO2, okay? So then it forms potassium bicarbonate and again it releases oxygen gas. So all these reactions are very important reactions because so these superoxides are actually used by breathing apparatus, right? So and in submarine industries and when uh, once they are trying to climb on the mountains and it is actually also kept in the cylinder to regenerate oxygen. So or if if anyone is going underwater, so they will keep potassium superoxide and so because this superoxide will generate oxygen to sustain the life. So firefighters or any others persons so that go in the aerospace, so they actually contain superoxides apparatus so to regenerate oxygens. So this is the beauty of potassium uh, superoxides, which is produced through the decomposition of the potassium ozonide, right? So potassium ozonides are thermodynamically unstable and it undergo decomposition to form potassium superoxide through the release of oxygen gas, right? So this is the beauty of potassium ozonides or any other kind of alkali metal ozonides. Okay, so in this way you can say that the alkali metals have high tendency to forms ozonides and all these ozonides so that is forms they are actually oxidizing, so they are used in various organic reactions where oxidation reduction takes place. So, and also to prepare uh, organic materials or inorganic materials, so it will also used, right? So you know that ozone uh, O3 is stable and they are highly reactive, right? Because of uh, uh, because so it will decompose O2, right? 2 mole of ozone, so that is decomposed into 3 mole of oxygen. It means 2 volume and it has 3 volume. 2 mole of ozone will decomposed into 3 mole of oxygen. So this is great source of oxygen actually, and this reactions and this decomposition is actually thermodynamically favorable, means this is spontaneously undergo conversion. Delta G is equal to minus 163 kilojoule per mole, right? So here delta G is negative. It means uh, the conversion of ozone into uh, oxygen, so thermodynamically favorable and undergo through the process of exothermic reactions, right? So this undergo exothermically, right? So all these superoxides, they undergo spontaneously into their conversion products. So this is the beauty of ozonides. So you can compare oxides, peroxides, superoxides, and ozonide and their chemistry, uh, which are involved uh, through the reaction of alkali metals. So oxygens are very important in the atmosphere, uh, which allotropes are different and the reactivity also different, and due to reactivity, so different types of compounds are formed and at industrial levels, so they can be used in the case of catalysis or sensor applications or electronic device or environmental remediation. So any kind of applications, so these oxygenous compounds can be used. Thank you students for listening and keeping patience during the video lecture. Okay.